Okay, good morning, everybody. I'm Stephanie Shearholtz from NASA's Office of Communications. Thank you for joining us today to discuss the path toward launching NASA's Boeing crew flight test. The agency is working toward a launch at 12:25 p.m. Eastern Time on Saturday, June 1st, for the first crewed flight of Boeing's Starliner spacecraft to the International Space Station as part of the agency's commercial crew program. Additional launch opportunities are available on Sunday, June 2nd, Wednesday, June 5th, and Thursday, June 6th. Joining us today to talk about the test flight and answer questions are NASA Associate Administrator Jim Free, Ken Bowersox, the Associate Administrator for NASA's Space Operations Mission Directorate at NASA headquarters, Steve Stich, the Manager of NASA's Commercial Crew Program, Dana Weigel, Manager of NASA's International Space Station Program, Mark Nappi, Vice President and Program Manager at Boeing's Commercial Crew Program, and Gary Wentz, Vice President of Government and Commercial Programs at ULA. We'll begin with opening remarks from our speakers before we take questions from reporters who are dialed in. You may enter the queue to ask a question at any time by pressing *1 on your phone. To remove yourself from the queue, press *2. We ask that you please stick to one question so that we can have a chance to get to everybody in the queue and identify to whom you are addressing your question. Please keep your questions focused on today's topic. To start, we will hear from NASA Associate Administrator Jim Free.
Thanks, Stephanie, and good morning. Thanks for joining us here today. Our NASA, ULA, and Boeing teams have spent the last couple weeks on analysis and testing for the Atlas V and Boeing Starliner to prepare for that first crewed flight test to ISS. Most importantly, I want to thank all three of those teams who've been working those issues, doing the analysis, thinking through all the scenarios, talking through things as a group, sharing information to make sure that everybody had the latest technical information so that they could make the decisions and feed things up to the managers, which you'll hear from today. And we are learning more about the systems every day. I also want to acknowledge to you all that, we've had our effort focused on addressing these technical challenges, getting to the right solutions. Each one of the technical issues that you hear about today, we're moving pretty quick and learning and kind of one flowing into the other, which we wanted to get all that information together to inform you and find the right time to do that, and that date is today. And I know there's some frustration out there about us sharing information in a timely way. I can assure you that the teams were working up until late yesterday coming to a conclusion. So we wanted to make sure that we had everything in line and in place for you, and you'll hear about that today from Steve and Mark and Gary. We do hear your concerns and comments about the flow of information, and that's my rationale. I'm happy to answer your questions about the rationale, but please know that getting this to you and getting the complete story has been our goal. You are an important part of telling our commercial crew story, and we'll continue to adjust our approach as we find the right balance of providing those updates as we learn more information going forward. So this morning we're going to hopefully remedy that. You will get a lot of information from Sox and from Steve and Mark and Gary to share with you where we stand and what we see as a possible path moving forward. I'll let them share those details as they have been very much in the working meetings to solve all these, and I can assure you they have been there. I appreciate everyone that's been involved, every individual working tirelessly to advance our understanding of this system as we move through each of these issues. It's our collective job to ensure we can fly this test flight safely and successfully, and to do that, we're going to understand everything about these issues and make the right decisions. That's why we're taking our time. We need to be deliberate about it. This is a new spacecraft and a new system. we've all challenged the teams to stay vigilant, and we've already, uncovered some of the unknowns that you always hear about when we talk about flight tests, and it's better that we've done that on the ground. We're going to keep learning from this mission, and I'm looking forward to increasing the knowledge of this system and flying with crew in this system as we get to ISS. This is all working towards giving us that dissimilar redundancy that's an important goal of the commercial crew program and essential to our continued decade of results aboard the International Space Station. It's preparing us every day for the missions to low Earth orbit. That'll open access to space to more people and is greatly informing our human exploration to the moon and beyond. With that, let me turn it over to Ken Bowersox. Go ahead, Sox.
Hey, thanks, Jim, and thanks everybody who's online for being here with us today. We really appreciate your interest in what we're doing. Yesterday, I had the opportunity to sit with representatives from NASA, Boeing, ULA, and Aerojet in a program board. I was only there for a small part of the meeting, but for the time I was there, it was just impressive to see the team working so thoroughly, so collaboratively through a very, very complicated issue. One of the things that popped out to me was this is why it's taken a while for us to be ready to discuss the issue. It's so complicated. There's so many things going on. We really just needed to work through it as a team, and it was impressive to see folks in that process as they converged and reached a plan for us to move towards launch. So thank you for your patience as we've worked through that. I know you're eager to hear more details, and so now I'll pass over to Steve to share some of those details.
Yeah, thank you, Ken, and thanks to all of you for being here today on the Friday before a long Memorial Day weekend. Appreciate your interest in human spaceflight and the commercial crew program, and I want to thank you for your patience as our joint NASA, Boeing, and ULA team worked through 3 specific issues over the last 2.5 weeks. Our goal today is to provide a comprehensive update to you on what we've been working on, what the resolution of each of these items are, and then to take questions that you might have. I would say I want to kind of set the stage for what it's been like for our team over the last 2.5 weeks. As you know, in commercial crew, we have a small, focused team, and we've been working very hard. You'll get a sense of that work today, minus the long hours and probably lots of coffee. So if we step back, we last talked to you after the launch scrub on May 6th. That was the scrub for the Centaur self-regulating valve, which we'll talk a little bit more about. I want to talk 3 aspects of the work we've been doing over this time frame: the swap out of that Centaur self-regulating valve and the checkout and how complex that activity was, a helium leak that we discovered in one of the doghouse manifolds on the service module for Starliner, and then I would say the implications for that leak and what it meant to the rest of the propulsion system relative to the deorbit burn. So let's start with the Centaur valve. That was the first thing that we worked on, and that was what caused the initial scrub. After the scrub, we got together and we looked at the data for that Centaur self-regulating valve. We determined that the number of cycles that it saw was outside of qualification. When I say we, this was a joint NASA and ULA team working side by side. So that valve had exceeded the number of cycles that we saw in qualification, so we couldn't go fly that valve. We obviously rolled back from the launch pad to the vertical integration facility, and we swapped that valve out, and Gary will talk a little bit more about that. We looked at all the data for the new valve, its performance. We went and looked at what we call the acceptance test packs. We didn't see any issues, nonconformances with that valve, and so we proceeded with that swap out. Now, that swap out was a pretty substantial activity, and that's why we adjusted the launch date from the May 10th to the 17th, and let me explain why that was a complicated activity. When the valve has to swap out, of course, the Centaur is an awesome stage. We've been flying it since the 1960s, but it's a pressure-stabilized stage, and so in order to swap this valve, the Centaur LOX tank and fuel tank had to be depressurized. In order for that to happen, we had to offload the weight on the Centaur, essentially. And so we used a crane to lift the Starliner not off of the Centaur, but to pull up on the Centaur and to take the load off the Centaur stage. In order to do that, we had to go back and do an analysis of all the load paths. And just to make sure, Starliner is certified to be lifted with a crane. That's certainly the way it's moved for weight and CG in the processing facility that Boeing has. It's also the way it's stacked and assembled on the launch vehicle. But we weren't unbolting it this time, so we were applying a little bit more loads to the same load path we used to lift it. We had to go through that analysis, working with the joint Boeing, ULA, NASA team. We did that. We did that operation over the weekend of May 11th and 12th and replaced the valve, and Gary will talk more about that. So we got through that. In the meantime, so that's the Centaur self-regulating valve. When we had the launch scrub on May 6th, we discovered in one of the helium, what we do after that launch scrub is we sort of safe the propulsion system. And part of that safing is to close what we call helium manifold valves. In each of the doghouses, those are the rectangular doghouses. There's 4 of them, port, starboard, top, and bottom on the service module. There's a helium line that goes into each of those doghouses. There's actually 2 helium manifolds in each of the doghouses. Those are used to open and close valves on each of the thrusters, the RCS thrusters and the OMAC thrusters. When we closed that system after the launch scrub, we saw a small leak in the port manifold 2 doghouse when we closed the isolation valves. It was a very small leak at the time. It was about 7 psi per minute, and that may sound like a big leak, but again, this is a really small volume. It's about 15 cubic inches of volume, and so when we close that valve, it doesn't take long to see a leak in a very tiny volume. That size is about the size of a softball, if you just think about that 15 cubic inches. So we saw that leak at the pad. We rolled the vehicle back to the vertical assembly facility, and we wanted to troubleshoot that leak a little bit more. And so we cycled that manifold open to bring it up to the flight pressure, which is about 750 pounds per square inch. And over a couple different cycles, we saw that leak rate grow. It went from about 7 to on the order of 50 to 70 psi per minute. So that gave us pause as that leak rate grew, and we wanted to understand what was causing that leak. In order to do that, we took off the cover on the port doghouse, and the Boeing team took a leak detector and looked all across that particular doghouse for leaks. It's a device that measures the helium that could come out of any point in the line. When we did that, we were able to isolate the leak to one of what we call a flange on a thruster that's called the P2D2 RCS thruster. This flange is about the size of a deck of cards, so it's a pretty small flange. But in that flange, there is a helium line that comes in, a MMH line, the fuel, and then NTO line, nitrogen tetroxide line, that comes into that flange, into the thruster. So we couldn't immediately open up that flange to look at what was going on and what was causing this leak in the helium system. So we had to do an analysis-based approach to go understand why we had this helium leak. We knew the leak was there, and we knew the size of the leak, and we actually knew in this flange which side the helium was coming out of, but we couldn't open it up because essentially the system was not safe for humans to be around and open that system up. So in addition to the cycle testing that we did, and we also looked at all the other manifolds, so there's 8 total helium manifolds. Only one has showed the leak, and that's this port doghouse helium manifold 2. So when we went through the troubleshooting for this, we figured out that the others are not leaking at all, but we wanted to understand what was the potential cause of this. And so we went and worked with a team to look at potential failure modes within that flange. We figured the most likely cause of the leak is a seal that seals that flange. In between the 2 metal parts of the flange, there's a seal much like you would have on any piece of your plumbing at home, a faucet or anything like that. There's a seal that keeps that interface tight so that the helium can pass through there. We had to do special analysis on the seal. We brought in seal experts from Boeing and NASA to look at that seal, to look at why it could be leaking. We figured out that this potential seal could have potential defect in it, and over time as we cycled it, that defect grew a little bit, and then that was the cause of the leak. We also did a structural analysis of that helium flange to look at when you have a seal, you want to make sure that seal is in the groove, if you will, and you want to look at the sealing force in that particular in the groove. And we had a finite element analysis done, a very detailed structural analysis to look at that squeeze on the seal. We felt like we had a really good seal there on all the other manifolds, and that's why we are confident in this case. There's 28 RCS thrusters across the vehicle, and 27 of those do not have a leak, and the one has a leak. We looked at also, with that leak rate, what if it gets worse? So how do we manage it in flight if that leak rate in this port doghouse helium manifold 2 got worse? We can accommodate leaks in multiple manifolds. Should that happen, should we be wrong about something, we could handle up to 4 more leaks, and we could handle this particular leak if that leak rate were to grow even up to 100 times in this one doghouse. So again, we needed to take the time to work through this analysis and to understand the helium leak and understand the ramifications of that, and that's why it's taken a little while to get back to you. Now, as we studied the helium leak, we also looked across the rest of the propulsion system, and just to make sure we didn't have any other things that we should be concerned about. We found a design vulnerability, I would say, in the prop system as we analyzed this particular helium leak, to where we didn't, for certain failure cases that are very remote, we didn't have the capability to execute the deorbit burn with redundancy. And what I mean by that is Starliner is certified to perform the deorbit burn with 3 different techniques. We can use 4 OMAC thrusters, 2 OMAC thrusters, and 8 RCS jets. If we had the right circumstances of failures, we could lose the 8 RCS jets. And so we wanted to take extra precaution to understand what could we do if we lost those 4 thrusters. We worked with the vendor of the thruster, Boeing, and our NASA team to come up with a redundant method to do the deorbit burn, to break it up into 2 burns, about 10 minutes each, 80 minutes apart, to come up with a 4 RCS thruster deorbit burn, and to regain the capability of the original system. And that took a little time for our team to go work through. Our guidance navigation control team, our structures team, our propulsion team, working hand-in-hand with Boeing and the vendors for these systems. And so we have that, we stored that redundancy for the backup capability in a very remote set of failures for the deorbit burn. So it took a little bit while to work through that. Because we had that particular system vulnerability, we decided to have a Delta flight readiness review, and that is primarily because some of the human rating certification details have changed from what everybody who signed the interim human certification document for CFT has changed. And so we're going to have a Delta flight readiness review on May the 29th to review both the leak and the changes to the way we would execute a deorbit burn in a remote set of failures. Long term, Boeing is going to explore options as we work towards certification after the crewed flight test to recover this redundancy. They are evaluating potential software fixes or other changes that we could have to restore that capability. I have spoken to the crew several times. We've stayed in contact with them. They've been a part of our meetings. Their job, as they know, is be ready to fly. They've been in quarantine now for a little over a month. They're in good spirits. They've tied into our meetings. They advised us to get some rest, which we're going to do now that we've set up for the launch on June 1st with the Memorial Day weekend, having our team, who's worked very hard for 2.5 weeks, to have a little bit of downtime. She says that the crew has also been in the simulator looking at various failure cases, some of them very extreme. Should we lose various thrusters and various manifolds, and they have flown all those cases in terms of rendezvous and deorbit and entry, and they're ready to go. Butch, when we talked to him, he said, we're in the business of discovery. We've obviously had some discovery over the last few weeks. He knew going into the flight we would have some discovery, and we've had it prior to launch versus in flight. And Butch says that they're ready to go and when we're ready to go. So what's next for us? We had a program control board yesterday where we went through the two topics in detail, that being the helium leak and the port manifold 2, and then the implications for the redundancy for the deorbit burn. We feel like we're on a good path. We have a few actions to close. We'll follow that up next week with a Delta program control board, and then we'll have the Delta agency flight test readiness review next Wednesday. And then the following day, if that review gives us a go to proceed, we'll roll the Atlas V and Starliner out to the pad, and we'll have the Starliner mission management team the next day. And then we'll come back and talk to you again next week after the review and let you know the latest status. And we've already talked about the launch dates. This is an important flight for us. It is not easy. I've been in human space flight for 37 years, and there's challenges with every single flight. There were challenges in Space Shuttle. There's challenges with the Orion vehicle that we're learning about as we flew that test flight, and there's challenges in every vehicle. So we'll work through those challenges one by one. I'm extremely proud of the teams. They put in long hours, worked over the weekend. The joint NASA, Boeing, ULA teams working through this integrated set of problems. We're really looking forward to having the second crew transportation system online soon when we're ready to go, and so we can continue to do the great research on ISS. This is why we do a test flight. There's always learning in every flight that we fly, whether it's a test flight or another flight. I'm super proud of the team, and Gary and Mark will add some more details. And with that, I'll turn it over to Dana Weigel.
Thanks, Steve. And thank you all for joining us today. I really want to extend my thanks and appreciation to the Commercial Crew Program, the Boeing, and our technical teams for the extensive analysis and work that they've done these past couple of weeks to get us to this point. They've really worked diligently to understand this helium leak and the implications associated with the fault tolerance and to make sure we can fly safely. These are some incredible teams, and I'm really grateful for the long hours they put in to get us to this point. From a station standpoint, we, of course, have followed along with all of the work. Our responsibility is really for the integrated operations risk realm, meaning for safe rendezvous, docking, the vehicle being on board station, and then undocking. And so kind of the sphere, if you will, around ISS. So we've worked through all of these challenges as well. We're really happy with the plan. We think we're in great shape to support integrated operations from a station standpoint. Of course, in the coming days, as Steve said, we'll have another flight test readiness review where we'll get the broader community to do another pass-through and look at all of the great work that the team has done. This is a really critical and historic mission for NASA, Boeing, and, of course, the Space Station program, as Steve mentioned, to get a second U.S. crewed vehicle capability up and flying to Space Station. We're going to take our time to get there. We're going to make sure that we do it right and that we do it safely. In other Space Station news, we continue to be really busy on board. The crew has been working on research. They've done a number of equipment replacements for us, and they're starting to step into some of the EVA preparations work in support of the upcoming spacewalks that we have in June. Next week on Tuesday, May 28th, we have a Progress undocking. That's Progress 86. And then we've got Progress 88 launching on May 30th at about 5:45 a.m. Eastern Time. It's launching from Kazakhstan. It will be carrying thousands of pounds of supplies. It's going to be docking to station on June 1st around 7:45 a.m. Eastern Time. So as always, a lot of things going on board Space Station, but we are ready to support Starliner, Butch, and Sunny when they arrive, and we are very much looking forward to supporting this historic mission. And with that, I'll pass it over to Mark Nappi.
Good morning, and thanks, everyone, for joining us this morning. Steve talked a lot about the leak and the we call fault tolerance issue. I'm going to repeat a little bit of what he said, but not to just repeat it and say it again, but to add more context on how we address these issues and how thorough the whole process was. Like Steve said, it's completely partnered. We utilize skills and experts from across NASA, Boeing, and our suppliers to get to the right answers and build flight rationale. Timeline of where we got to, we scrubbed on 5-6, rolled back, ULA went first and worked on the valve, and then we got right in there and started looking in at the leak that was discovered on the scrub operation. By 5:13, we had located the leak. We had checked all the potential sources. There were over 30 different sources that the team had identified. And then we went back a couple days later and we proved to ourselves that the leak was stable. That's all good data, but that really starts the process of, okay, how do we solve this? How do we get flight rationale? How do we determine what we're going to do next? So there were a couple of questions that we had to answer. First, why wasn't the seal in this joint sealing? Exactly why. Will it get worse? How much worse can it get? Does the condition can the condition exist in the other flanges? Is there some kind of common cause? And then if we were to accept this, would it be operationally manageable in flight? And can we tolerate it, or are there workarounds? So that really is what took a lot of time for us to go resolve, was answering all these questions. And of course, during answering these questions, we found that design vulnerability that Steve talked about. He said it was remote, and I'll point out that it is very remote. When we looked at the fault tolerance of the system, there are over 17,000 potential combinations of failures, and what we found was that 99.2% of them were all addressed, and this small 0.77% is what we found. So that puts into context the remoteness. To address these issues, like Steve said, we just covered the landscape with all these modeling experts and suppliers and system experts, designers, and then even did independent verifications of the results once we got them. We met nearly every day, either in some kind of mission management team or a control board, to hear status, to hear results, and to get everybody installments of what we had learned each day. The teams, went under some pretty immense scrutiny to be able to explain the issues that we were finding. They got pressure tested on their conclusions, and then, eventually we got the community bought into our flight rationale and the actions. So bottom line, Ken said that these are complicated issues, and they are, but it boils down to a couple of things. On the leak, the design meets the intent for this application, so it's not a design problem. We don't believe we have a common cause where this condition exists across all the other flanges, which is good news. And we are comfortable with the causes that we've identified for this specific leak location. And if the steel completely blows out and we had just metal-to-metal contact, we know we can manage this. So this is really not a safety of flight issue for ourselves, and we believe that we have a well-understood condition that we can manage. For the fault tolerance, or as Steve called it, the design vulnerability, again, extremely unlikely set of multiple failures that would have to occur for us to get into this situation. And if it happened before we undocked, we wouldn't undocked. So we would manage it and be able to address it there. If it was to happen after we undocked from station, again, extremely unlikely, but we have now a solution with this 4 RCET jet scenario that Steve walked through. It's backed by test data, it's backed by flight data, and the guidance and navigation modeling have reinforced that this technique will work, and of course we've had independent verification on that. The crew has tested it, and we feel very comfortable with the situation that we have. So again, very low level of risk for an unlikely set of failure scenarios, and we have a safe for flight vehicle that we need to put just the final set of flight rationale together in the coming days, and we'll be ready for these sets of meetings that we have in front of us. There's minimal work left in order to get to launch next Saturday. We have of course, a lot of meetings to go through with control boards and the Delta FR that Steve talked about in the L-1 and L-2 day. We chose 6-1 for a multitude of reasons, but one of the big reasons was to give the workforce the weekend off. We've worked some really long hours, 7 days a week to get to where we are today, and we just thought it was a good idea to take a break this weekend, reset everybody's batteries, and then gear up for a launch next Saturday. Remember, this is a test flight. We're still learning. We'll continue to learn. We really like to thank NASA, ULA, and our suppliers on how they came together with our Boeing team to execute this mission and to get to next Saturday. Thank you, and I'll turn it over to Gary.
Thanks, Mark. First, I want to thank all of you for participating today and your interest. I speak for the entire ULA team that we're really excited as we progress to the next opportunity to fly the crewed flight test. Like Mark and Steve have talked, we've spent the last 2 weeks working integrated collaboratively together between Boeing, ULA, NASA, and suppliers on both sides, working through the issues and preparing the hardware for flight. Steve walked you through a pretty extensive explanation of the process that we went through to replace the self-regulating vent valve. Structurally, we had to relieve the load off the Centaur when we got back to the VIF. So we attached that GSE to Starliner and applied that force, which we refer to as putting the Centaur stage in stretch. So it transitions from pressure stabilized to structurally stabilized with that assist. That enabled us to depressurize the tanks and get in to access the valve and make that replacement. So the team replaced that valve, then subsequently repressurized the stage and conducted functional checkouts of the valve assembly and did some system purges to make sure everything was operating as it should, and then put the rocket back into a configuration that would support continued processing. So after the scrub on May 6th, that took us to around May 13th to get all that work completed to be able to proceed. And then we worked, from an integrated perspective, since Starliner's on top of the rocket, with the Boeing team to make sure that they had all the support they needed to look into the helium leak in the VIF. The rocket remains stacked there in the VIF and poised, ready to support as soon as the NASA, Boeing, and ULA team are ready to go to flight. Just forecasting going forward on the activities, we will likely spend Tuesday and Wednesday of next week performing continued closeouts of the vehicle. In parallel, we'll do the flight test readiness review with the NASA Boeing team. And then subsequent to that, we would plan to roll on Thursday of next week. Friday, because of the launch time being earlier in the day, we'll have a crew sync day, get the team realigned for a launch attempt on Saturday. And so look forward to any questions. Appreciate your interest. Thanks. Stephanie, over to you.
Okay, thank you. Thanks for all those opening remarks from our speakers and the detail that you shared with us. We'll now address your questions. We do have quite a few people on the line, and I know you all are eager to ask questions, so please do remember to identify to whom you are addressing your question, and please do stick to one question so that everybody gets an opportunity to ask their question. If you need a reminder, you can press *1 to get into the queue. If your question was asked, you can remove yourself by pressing *2. So let's jump right in with Bill Harwood from CBS News, please.
Yeah, thanks, Stephanie. It's Bill Harwood, CBS. I think this is for Steve. I'm not sure I understand the loss of redundancy issue for entry. I mean, that's something obviously you discovered, I'll say out of the blue, while you were investigating, across the propulsion system, but I don't understand what gets you into that situation, and why. Well, I just don't understand it. So maybe if you could provide a little bit more detail, I'd appreciate that. Thanks.
Yeah, Bill, that's a good question. It's complicated. It probably is not so much for entry, I would say, but it's really for execution of the deorbit burn. So the cases that we would worry about here would be a case where you would lose two manifolds in what I would call adjacent doghouses. So in other words, it needs to be the port doghouse that you would lose. And this is really a little bit independent of the leak per se. So if you lost the right manifold in port doghouse and, let's say, the top doghouse, the way the software works for the orbit is when you lose, for the OMACs, for example, they're big thrusters. They are about 1,500 pounds of thrust. And so in the 4 OMAC version of the orbit, you would have one thruster firing in each doghouse, one OMAC thruster. In the 2 OMAC case, you can have them firing in, I would say, doghouses that are across from each other. But if you were to lose 2 adjacent doghouses, essentially it takes out any OMAC deorbit capability, and you don't have the 8 RCS thrusters. And so that's the case we would have to downmode to the 4 thrusters. So it's a pretty diabolical case where you would lose 2 helium manifolds in 2 separate doghouses, and they have to be next to each other around the clock, right? If you think about these doghouses going around the clock on the Starliner service module, they'd have to be total loss of the manifold and right adjacent to each other. And so that's why, as Mark said, this is a pretty remote set of failures. And so we figured that out, and we have a backup way to do the deorbit burn with 4 thrusters, breaking the burn up into 2, and it's a pretty deep failure case. This vehicle has lots of thruster redundancy.
Okay, thanks for that explanation, Steve. Our next question comes from Jeff Faust of Space News.
Hey, good morning. Question for Mark. If you're not able for any reason to go on June 1st or any of the other dates in early June, how much longer can you remain stacked on top of the Atlas V before you would have to destack to address any sort of propellant issues or anything else life limiting on the spacecraft that would need to be refreshed? Thanks.
Yeah, we've looked at that, and Starliner is really not the governing factor here. It really is the launch vehicle. So I'll turn it over to Gary to address where we would go if we miss these opportunities.
Yeah, Jeff, that's a good question. As you guys know, there's a series of things that we refer to as limited life. We have batteries. Primarily, we have a large number of tests that we have to conduct on a regular basis within the ordnance system, focused on FTS, safe and arm functions, and other pyro valve cartridges, things like that we would have to repeat tests on. And so those expire, I will say, throughout June and into July. And so from a limited life perspective, we would work through those items, do those retests, and swap out the hardware that's needed to be able to continue to support. In parallel, we'd have to work with our other customers for the manifest for the rest of the year to make sure that we can deconflict, and some of it will come down to a prioritization of missions throughout the rest of the year. And so we would be looking for our NASA and primarily Space Force customers to work with us to identify those priorities and to sequence the mission. So that would be forward work. Just like right now, we have nothing that precludes us to get through the early June launch attempts from a limited life perspective. So we're clear to get through these.
Thank you, Gary. Next, we'll move on to Michael Sheets from CNBC.
Thank you, everybody. This is Michael. Steve mentioned that the leak was stable, but am I correct in understanding that you're not stopping the leak, you're just simply monitoring the leak and moving forward as long as it remains within those leak tolerances that you mentioned? And Mark, you also mentioned that you don't believe you have common cause with the flange issue that you identified. Can you explain why you don't think there's a commonality between this issue and that's potentially happening with one of the other flanges?
Yeah, I'll answer the first part of it. We have cycled that leaking flange and the manifold associated with helium manifold 2, and we have seen that the leak rate isn't changing. And so what we plan to do in flight is essentially that manifold gets open. All the helium valves get open during what I would call prop activation during the launch countdown. You want to have all the thrusters available for launch should you have the unlikely chance of a mass on the board. And so it remains open, and we'll be feeding that leak, and we can actually see kind of what the leak rate is when we open that system on the pad, and we can convince ourselves that the leak hasn't changed once the system is opened. We would keep that system open all the way through docking, and then sometime after we docked at ISS, we would then close all the heliums. We sort of deactivate the prop system once we dock to the International Space Station. And once we close that manifold and all the other manifolds, once we dock, then we can kind of see that what the leak rate has done. And then the plan for undocking is we would open all the heliums and have everything available for undock. And so that's sort of how we'll manage it in flight. And then, Mark, I'll let you take the second part of the question.
Sure. So the common cause, what we looked at was the design first to see how the design intent was met. And after several reviews with several experts, the design intent has been met. So that makes us feel comfortable that had the seals are installed properly in the other flange locations, that this doesn't exist. An evidence that this doesn't exist is the fact that all those other flanges are not leaking. They are solid, no leakage whatsoever. So that brings us to the conclusion that we have a pretty good installation on those seals and those flanges.
And I would add a little bit to what Mark said. We went and looked at the vendor. The vendor provided 59 seals that we looked at to inspect them to see if there were any defects on those seals. We also looked at the dimensions of those seals. We didn't see any issue with any of those. Those are from the same lot. The way things happen in spaceflight is you want to make sure you have lot traceability on the hardware you're flying. So those are on the same lot that were installed in the service module. And then the structural analysis really said that the joint should not leak with this particular seal configuration. Anytime you have a seal, you have something called squeeze. Essentially, are you really pressing on that seal, and that seal, that press of the two flanges on the seal, and then also the pressure that comes in keeps that seal in place to make sure we sealed. So we have pressurized the manifolds multiple times. The only one that's leaking is this port doghouse helium manifold 2, and then we have an analysis that backs that up that says, we don't expect the others to leak. And I think that's the confidence that we have that we don't have a common cause failure mode.
Thank you. Next in the queue is Jonathan Seri from Fox News.
Yeah, good morning. Thanks for doing this. My question is probably for Steve about those backup launch dates on June 2nd, 5th, and 6th. Do you know what times of day you're looking at for each of those backup days?
Yes, I do have that information. The launch time gets a little bit earlier, so June 2nd, the launch time is 12:03 p.m. Eastern. And then we move into the morning on June 5th, 10:52 a.m. Eastern, and June 6th, 10:29 a.m. Eastern.
Thank you.
Thank you, Steve. Next question is from Gina Sinceri from ABC News.
Yes, thank you. You mentioned earlier that the helium leak wasn't something you were monitoring during the actual launch attempt. Is it not necessary to monitor this? I just don't understand that. If you could explain it for me.
Yeah, let me try, and then we'll see if Mark has anything to add. The helium leak is difficult to monitor during the launch count. We can detect helium leaks, but the way the system works is when you activate the prop system and you open up all the plumbing, all the valves that allows helium to flow from the tanks inside the service module throughout the system into those dog houses, it's very difficult to see a leak that's this small. So we also think that this particular seal likely, because we talked about 27 of the 28 flanges aren't leaking, we think, and we haven't had a chance to put eyes on the seal, obviously, because we can't take the flange apart, but we think there was likely, in talking to seal experts, there was some kind of defect in this seal. When they're manufactured, they have some propensity to have a kind of a place where the two sides come together, like a seam. That could be a defect, or when they trim some of the material as it comes out of the mold, maybe there could be a little nick there, and then as you cycle it a few times, perhaps that the leak got worse. And so it's very difficult to see a leak until you isolate the manifold, and that's when we saw the leak, is when we isolated the manifold after the scrub, we identified the leak.
Thank you, Steve. Our next question comes from Marcia Dunn from the Associated Press.
Oh, yeah, it's probably for you, Steve, again. As I recall, there was mention of this helium leak during the countdown before the scrub. And if not for the rocket valve trouble, would you have launched back on May 6th, given this small leak as it stood back then? And if so, what's the worst that could have happened if the leak grew in orbit? Thanks.
Yeah, that's a good question, Marcia. We didn't see the leak during the countdown per se until after the scrub. So we had no way to see the leak until the scrub. So it was after we scrubbed for the Centaur self-regulating valve that we saw the leak. So if we hadn't had, I'll answer the question this way. So if we hadn't had the scrub with the Centaur self-regulating valve, we would have launched. And likely when we closed the manifolds after docking, we would have seen the small leak, and we would have been able to manage it in flight just fine. We would have done the same things, we have at least 7 or 8 days while docked. We would have done the same kind of analysis relative to the size of the leak that we could accommodate. We would have looked at the back half of the mission relative to how many feet in the leak after you undock and what that meant for the orbit, and we would have managed it in flight.
I'd add, Steve, we don't get the service module back, so there is some silver lining to being able to see this, having the scrub take place and being able to see this leak, because we now know exactly where it was. We have done all the work that we just talked about to understand the root cause, and that's going to help us with improving the system in the future. So, had we launched, obviously it would have been a safe flight and a successful flight, but we would have not known as much as we know today.
Okay, thank you. Next question comes from Irene Klotz of Aviation Week.
Thanks, Stephanie. So for this next launch attempt, now that the leak is known and well characterized, is there anything that can be done to monitor it during the countdown, or is it going to be the same situation that it was on May 6th, where it won't even really register unless there's some other issue that happens that causes you to close the manifolds down? I'm sorry, that's probably for Steve or Mark.
I'll take a cut and see if Mark wants to add anything. Now that we know the approximate leak rate, the size of the leak, the 70 to 80 pounds per square inch per minute, We have characterized what that leak looks like with the manifold actually pressurized, and we can see repress cycles from the helium tank. And so it'll take us maybe an hour after we bring the system up, but we can look at how those repress cycles are going and determine if the leak is about where we think it is today. And so that's what we're going to do pre-launch is we'll watch the system repress. If it were to change or grow, we would then go isolate that manifold and see if we have anything else going on in another manifold. We could do that. So hopefully I answered your question.
I'd only add that our mission director, Laura Kane, and our mission ops team have looked at this information and have developed a plan in case we see something different, or if we see it again, what exactly we're going to do and what the limits are on taking action. So we're prepared to go into the launch countdown.
Okay, thank you both. Next up is Chris Davenport from the Washington Post.
Hi, thanks so much. For Steve, I guess. Just real quick, I know you were looking at the helium leak, and then that's when you discovered this redundancy issue on the deorbit burn. But is that related to the helium leak? Is the helium leak causing this concern about the redundancy? I just wonder if they're related. And you had said that this was a design vulnerability. So I'm just sort of wondering, why it's just being caught now if it's something you think you should have been caught earlier. Thanks.
Yeah, that's a very good question. Yeah, I think the helium leak itself caused us to look a little bit more detailed at the manifolds and how the thrusters were architected off of each of those manifolds. And then we started looking a little bit more detail at some of these failure cases where you lost an entire helium manifold in one of the doghouses and then in others. And that's when we started to realize that when you have a total loss of a manifold, you could lose. In this case, on manifold 2 in the port doghouse, there's 6 OMAC thrusters and 4 RCS thrusters associated with that. I think that's when we started to realize that in this particular case, for this very remote set of failures, we could lose the redundancy of the 8 RCS aft-firing jets for the orbit. So it just took us a little time to figure this out now. Question is, should we have seen this earlier? I think maybe in a perfect time frame we might have identified this earlier. My memory from shuttle is we had certain failure cases where we identified some kind of redundancy issues. We'd have to go back and get this set of circumstances. I do remember one time and I don't remember if this was the liquid hydrogen eco sensors or where, but we had great redundancy in the system. However, like in a wire bundle, we figured out that we were running all the signals for a particular piece of instrumentation or avionics through that same wire bundle. So effectively, we didn't have redundancy, and we didn't have separation on the wire bundles like we should have had. So I think these things happen in human spaceflight. It's very complex to look at the architecture for power and data to each thruster, then how you get the fuel and oxidizer from different plumbing to each thruster, and then the helium source for each thruster. So there's probably, on this particular design, a few more things that go to each thruster that could lose the thruster. And we had identified almost all of them, but this one set of unique circumstances we didn't quite catch in our review.
Thank you, Steve. Our next question comes from Joey Roulette of Reuters.
Hey, thanks. Question for Steve. You say you think the leak, just so I'm understanding correctly, you say you think the leak was caused by a potential defect in the seal. And shouldn't the cause of the leak of the weak seal be something that you guys kind of want more certainty on before flying, or do you have more certainty on a different scenario? And if not a defect in the seal, for example, what else could it potentially be?
Yeah, it's a very, very good question. When we talk to the seal experts, there's a few different kinds of things that can happen to the seal. You can have, like I said, a manufacturing defect. You could potentially have an installation error where you put the seal in and it got squeezed or crimped a little bit. It turns out that the best thing for the seal is, like we're going to do in flight, right? We're going to go pressurize that seal for flight and then only depressurize it. Won't take any pressure off if there's no leak at all on orbit. But it could have been a defect, could have been a manufacturing defect, could have been an installation defect. On our fault tree, could have been some FOD in the system, some kind of small thing that maybe rubbed a bit as we pressurized and unpressurized it. So those are kind of the things that we would say are on the fault tree. The beauty of our flight rationale for CFT, the crewed flight test, is that we have looked at the other 27 seals and the other 27 flanges by doing a long-term decay check when we were in the VIF. I think it was almost 3 days where we sat and we had the manifold closed. We weren't really feeding helium into the system. Those other manifolds were leak tight, which meant the flanges on those manifolds were leak tight. And we also, have cycled it several times. So we put the other flanges, the other 27 flanges, through the same sorts of things that caused the leak on this particular flange. And so we feel fairly confident that we won't have leaks in the other flanges. And if we had a leak, it might be a very small one. So that's sort of our primary flight rationale on the other flanges.
Thank you. Our next question comes from Micah Maidenberg from the Wall Street Journal.
Thanks, Stephanie. Hey, Steve and Mark, you've both previously talked about how you believe Starliner was ready for that May 6th flight. And then the leak, the design vulnerability weren't discussed sort of in the run-up to May 6th. Is there something missing in the readiness analysis? And are you concerned, that these issues weren't ID'd, sooner? Thanks.
I'll let Mark start, and then I'll add to it.
Well, see, the hardware issues or hardware failures are just part of our business. They're going to occur as we do launch preps. They're going to occur in flight. There's no human-rated vehicle that doesn't experience this kind of anomaly. And the important thing is how do you react to it and how do you learn from it? And I think that's what you've heard today is how we've done that. So no, I'm not concerned with our process that leads up to this. We have multiple redundancies in our system, like Steve talked. We have a case here which was extremely remote that we missed, and if there are more out there, they're going to be in that same category of extremely remote.
And I just added, this is a test flight, and we're gaining experience with this vehicle, and I think our space shuttle experience would say almost in some respect all 135 flights were test flights because we learned something on every single one of those flights. This is like STS-1, the first shuttle flight in some respects of a new vehicle, and so I think we're still learning. This particular leak, I don't think implicates the design of the seal or the flange. It's just maybe a defective part. I go back to my shuttle experience where we had at times leaking helium regulators and things like that we had to manage. And in cases we actually lifted off with some small leaks in the helium regulators that we could manage in flight. So it's a tough system. This is a high pressure system, and helium's a very small, tiny molecule, and it tends to leak. We can look at our Artemis experience with another tiny molecule, hydrogen, and they have had lots of struggles with leaks as well. But I think we understand this leak, and then I think we understand the rest of the vehicle. We got to see the vehicle as it powered up. We got to see the vehicle on the pad and understand how it was performing. And, we don't have any concerns for any other areas at this point.
Thank you. We are 1 hour in, but we'll keep going to try to get to more of these questions that are are lined up. So the next question is coming from Kristen Fisher from CNN.
Hi, this question is for Steve or maybe Mark, and it's really a follow-up to Marsh's question. I just want to be crystal clear here that there was zero discussion of a helium leak before the decision to scrub, and I ask because that just differs a bit from what I'd initially heard. And then second, if I could just get an update on the crew, when they'll come back to the Cape, that sort of stuff. Thanks.
Hey, Steve, I think you've said it. I'll try it as well. I sat, and both Steve and I were in the control rooms for the launch countdown, and it wasn't until the scrub activities, post-scrub activities, that we discovered this leak. So it was not talked about or seen until the post-scrub activities. And the latest that we have on the crew, Steve, you can check me here, but the latest we had on the crew was that they were going to be flying to Florida on the 28th.
Yeah, that's what I have as well, Mark. I think they're flying down. They usually travel about 4 days prior to launch, and I think they're traveling on the 28th, the day before the Delta agency FTRR.
Okay, thank you. Next up is Lauren Grush with Bloomberg.
Hi, thank you so much. Sorry if I missed this, but I'd like to expand on what I think Mark spoke about regarding metal-to-metal contact of the seal where the helium leak is just to fully blow. So can you just explain what that would mean and how you would manage that? And I also remember there were some issues with a few thrusters on Starliner during the uncrewed test flight back in 2022. I just want to know if this helium leak and or the deorbit burn redundancy problem are related to those issues. Thanks.
All right, so I'll try this, and then Steve, you can jump in. You were here for the OFT-1 activities. I don't believe those were related in any way to what we're talking about today. And when I was referencing the metal-to-metal on the flange, what we did was we said we wanted to understand the leak rate, and if it was to get worse, what could we tolerate? So some testing was done, and analysis backed it up, that if we were to remove the seal completely and just torque the flange down, the leak rate would not exceed our capability to manage that leak. So that made us very comfortable that if this leak was to get worse, it would be acceptable for flight. Steve, over to you.
Yeah, thanks, Mark. Yeah, on Starliner 1, we had some RCS thrusters fail off. Now, those turned out to not be real thruster failures. Those were essentially the software in the integrated propulsion controller failed off a totally good thruster. And so we've made some changes in the software and the firmware to go fix that, and so we shouldn't have those happen again. And we actually recovered those RCS thrusters. We did have two OMAC thrusters that failed off right during the orbit insertion burn on OFT-1. We went and ran the potential failure mode for those down. Again, as Mark said, we don't get the hardware back, unfortunately, in the service module because it gets disposed of in the ocean. But the likely cause of those, based on the signature and data that we saw, was some sort of blockage that perhaps was in the in that manifold and on the fuel or oxide up to that thruster. And so we went and did extensive borescoping and cleaning and making sure that we didn't have any kind of the FOD that might have been present. Did extra checks on the vehicle. So we don't think we're going to have the OMAC issue we saw in OFT-1, and that gives us confidence in going to fly with this small helium leak.
Thank you. Next up is Stephen Clark with Ars Technica.
Hi, thank you. I think my question's probably for Mark or Steve. Just a question on the seal. Apologies if I missed this earlier. Can you talk about what the seal is made of and how big the dimensions of the seal? And what would, if you elected to replace the seal to, resolve this leak, with a hardware solution, what would that entail? Would you have to bring the spacecraft back to the C3PF to do that?
Yeah, let me talk the material for the seal. I can get the details. It's basically a rubber seal think of it as a ring almost like you would have in your faucet in your sink if you do your own plumbing work. The size of it, it's pretty small. If you have a button-down shirt on like I do, it's roughly the diameter of the button on your shirt, so it's pretty small. And then the thickness of it, it's about the thickness of, it's pretty thin. We would call it a 40 thousandth of an inch. And if you took 10 sheets of paper and stacked those together, that's how thin this seal is. And so that is why we likely think, because it is such a thin seal in terms of thickness, that maybe there's a little defect in it. That's the most likely failure mode. When we talk to the vendor, they have used this particular seal in other applications and have seen, good reliability from it. We saw good reliability on OFT1 and also OFT2 as well with these particular seals. So that gives us some confidence in it. And then I did misspeak. I think the failures I talked about, I think I said OFT1 by mistake on the thrusters, the RCS thrusters and the OMAX, and it was really OFT2. And I'll let Mark talk about what we'd have to do if we were to go repair the leak.
Yeah, we did look at what it would take to go ahead and change this seal out. And so the key piece is that this is in the hyper system, the MMH fuel and N2O oxidizer that is in that flange. So we characterize that as a hot system. It's hazardous to go do that work. We would not be able to do that work out at the VIF, so the vehicle would need to be destacked, brought back to the C3PF, safe in one way or the other, which would most likely involve deservicing the vehicle and then going in an escape operation and changing the seal out. So it'd be quite involved.
Thank you for that. Will Robinson-Smith is next up with Spaceflight Now.
Yes, hi. So much for taking the time to answer our questions, and apologies, I'm fighting a cold, so hopefully my audio comes through clearly. Question for Steve as far as the timing of the mission, and maybe for Mark as well. You mentioned that there may be some alterations to the deorbit burn should the need arise. In the ascent and going into docking, as Butch and Sunny are doing some of the manual checkouts of Starliner, are there any thoughts to change the timeline or some of the manual operations that they're going to be doing? Can you just go into a little more detail on what that may look like? Thanks.
Yeah, this is Steve. Right now, we don't envision any change to the flight plan relative to any of the crew manual flying objectives that they plan to do, or any of the rendezvous. As Dana said, that we've looked at the rendezvous profile. We've looked at redundancy. We don't see any issues relative to this particular doghouse leak. And I want to clarify the change at the end of the flight. We nominally plan to do the deorbit burn just the way we have on OFT1 and OFT2. We plan to do an OMAC burn. We have redundancy and we can handle an OMAC failure and still execute the deorbit burn. It would be in this pretty remote case where we lost the helium manifold totally in two different doghouses. And as Mark said, in the port doghouse, if the leak rate were to increase, we can feed that leak. We have the way to see what that leak rate is during real time, even on the way to station if that leak rate's increasing. We could always isolate that doghouse temporarily, preserve helium, and then reopen it for critical burns or critical parts of the approach to ISS. So we have lots of options to manage that. And then the nominal plan is to execute the mission as advertised, as we've planned for many years. And again, the deorbit burn will be with OMAX, just like we planned to. It would only be in this remote set of failures that we would have to go to the two burns with the 4 RCS jets. And I do hope you feel better.
Okay, next up is Marina Karen from The Atlantic.
Hi, a question for Mark. Before May 6th, your estimate for the probability of loss of crew for this mission was 1 in 295. Given the issues that have come up since, where does that ratio stand today? And a real quick question for Jim. You mentioned that part of the delay for giving us public updates is because you said we're moving pretty quick. Why? What is driving that pace? And is there a reason you're not wanting to slow down as you work through these problems and even destack the vehicle to reach that seal? Thank you.
So Steve, you can add to this as well, but our risk posture, our probability is not related to this area at all. It's related to a different cause. So no, this does not affect that at all.
Yeah, I would agree, Mark. Yeah, go ahead, Jim.
I would say the information was flowing really quick. We're moving quick to address the issues. Steve and his team and Mark and their teams were meeting every day, doing analysis, getting new information. They've shared with you kind of how some of this progressed, and we're never moving too quick that we're compromising safety. We're moving quick to get the information, do the analysis, and get to flight. But we're not going to fly until we're sure we're safe.
Thanks, Jim. Next up is Anthony Leone from Spectrum News.
Hello, everyone. Thank you for taking our questions today. This one is for Steve. So just to recap, we're going to launch even though there's a leak. So my question is, how confident are you that this issue that has caused the leak because of the seal in the thruster control system, are you confident that won't worsen during the launch vibration plus being in orbit and then re-entry? I know you're talking about that, but it sounds like there's definitely some concern if you guys are thinking of backup plans. Thank you.
Yeah, good question. I would say the reason we're confident, two different aspects of confidence in flying with the leak is, one, we've characterized the leak through various pressure cycles, and the leak is relatively stable. And then we've, as Mark said, done a couple of bounding analysis. We actually, as Mark said, took the whole seal, assuming the seal is not in this particular flange, and we can manage even that leak rate, which is 100 times worse than this one. And also, we've looked at the other manifolds, and they're not leaking. And then we have a really good analysis of the structure, and then what the stresses are in this particular seal. And I would say the ascent time frame is not going to put a lot of stress on this particular seal. What happens when the seal is pressurized, or you have pressure across it? I mean, it takes a certain set in the groove that it's in, and it expands against the walls, and it's in a stable configuration. When we've looked at analysis of what the stresses are in the particular seal, it's almost the worst case is when we cycle it. We cycle it open and then closed. That's where we think, when the leak rate increased, we think whatever the defect is in the seal, we were exacerbating that defect and making that grow a little bit, whether it be a little crack or a little imperfection in the side of the seal. With this kind of pressure, it doesn't take a very big defect to get these kind of leak rates. And so we think it's stable. That's why we think it'll be fine during ascent and the rest of the flight. And we also, on the other side of it, we looked at, well, what if it grows? Can we manage it? And that's what is giving us confidence to proceed into the flight.
Thank you, Steve. Next up is Elizabeth Howell with Space.com.
Hi, everybody. Thanks for your time. This probably is for Dana. Can you explain how long we can hold that port open for Starliner if the delay persists beyond, say, early June? What sorts of factors you might have also in terms of spacewalking and other activities that might influence future launch dates? Thank you.
Sure. Let's see. We're pretty flexible all through the summer. Currently, we're planning the spacewalks on targeting June 13th as the start of the first one. We'll keep them about a week apart. But we have flexibility, so there's no specific driver for exactly when we do them. We can do the spacewalks while Butch and Sunny are on board. We'll stay away from things like docking, undocking, and major handover days, but we've got flexibility in terms of where we put them. We've got Northrop Grumman flight planned for August. That's a berthing vehicle, so that's also not an impact to us. So other than actually deconflicting the specific berthing day versus a CFT docking day, which is just a really small cutout, that's not an issue. In fact, the extra helping hands on board could be helpful with that kind of a cargo mission. So really, the next activity that we have would be our next crew exchange out in the August time frame. That's the next time a docking's moved, and of course, those are things we can adjust to if we needed. So we're pretty open and flexible on station and can move things around.
Thanks, Dana. Next up, we have Andrea Weinfelder from the Houston Chronicle.
Hi. I'm still trying to find a very high-level way to describe this deorbit redundancy for our readers. Steve, is this the gist? So you have a variety of thruster combinations that can be used to ignite the engines and leave Earth orbit to come home. You identified a very unlikely scenario where certain thrusters could go out and you didn't have a way to come home safely, but you've since found a solution. Is that like a fair way to say what's going on here? Thank you.
Yeah, I think that's exactly the way we would say it. We have a lot of redundancy to come home, and like we said, we have a 4 OMAC option, which and redundancy on those thrusters. If you just look at the number of thrusters we could use, there's redundancy there in each of the doghouses. A 2 OMAC option. And it's really only a very narrow case that you could get into where the normal backup, the third backup option, which is or the second backup option is the RCS thrusters, which we normally use 8 of those. Now, instead of having to use 8, we would use 4. Did I answer your question, hopefully?
Yeah, thanks, Andrea. And thanks, Steve. Next up in the queue is Isam Ahmed from the AFP.
Hi, thanks for taking my question. Just a couple of parts. First, to check my understanding is correct. You'll monitor the leak in the pre-launch period, and then Starliner will fly, dock with station, and you'll check on the leak again then. And the second thing was just for context, how common or uncommon is it to fly a crewed spaceship when a leak is identified as being present? Thank you.
Yeah, again, we'll once we activate the propulsion system, we'll be able to take a look at. We'll use the repress cycles in the helium system to take a look at the size of the leak, and we can do that once we pressurize out at the launch pad for flight. That happens about 4.5 hours prior to launch, and then we'll watch it. It takes about an hour for things to stabilize in the system, and then we can take a look there. We'll get another look at it, as you said, after we dock, and then we can see what the pressure decay rates are and compare that to what we did back in the VIF. And then, we have flown vehicles with small helium leaks. We've flown the space shuttle with a few regulators in that OMS and RCS system that were leaking, and we've had a couple of cases with Dragon where we've had a few small leaks as well. So.
Okay, thank you for that. Next up is Tim Fernholz with Payload Space.
Good morning, everybody. Thank you for taking the time. I just wanted to confirm, is this the same propulsion system? I know the issues are different, but this is the same propulsion system that was supplied by Aerojet. And I was curious, does the design vulnerability you've identified now, is that something that you would want to redesign ahead of another flight?
So I'll take that. The system is provided by Aerojet Rocketdyne, and they were extremely helpful in having us understand this problem and come to a conclusion that we came to and establish the flight rationale. So that part of the question is right. So Can you ask the second part again?
Mark, I think that's, yeah, go ahead, Steve. I think he was asking about do you want to address the other item prior to another flight?
I think Mark was still. Are we gonna continue to have this for future flights, and is it the same mode we want to be in? I think I would say we're going to go look at options to see what we can do to remediate this particular situation we were in. We know there's potentially some software options. Maybe instead of having just 4 jets, we could have 6 jets. And we'll go work with, as you said, the vendor, Aerojet, to look at the thruster itself and see if there's anything we can do there. So, but Mark, you can add to it.
No, thank you. I just slipped my mind what the question was, but we've already looked at 4 or 5 different solutions that we would take forward, and we will apply one of those for the upcoming flights.
Thank you both. Next in the queue is Jim Siegel from NASATech.net.
Hi, everybody. Thank you for taking my question. And by the way, thank you also for such a detailed and well-prepared briefing for us. I suppose this is a question for Stephanie. Have you scheduled the date and time for the remote camera setup? Thank you.
Jim, I don't know the answer to that, but we will get that information and get back to you on that one.
Thanks, Stephanie.
Yeah, and we'll be looking to put out, an advisory with additional information as we work through all the replanning.
Okay, is that going to happen today?
I don't think it's going to happen today, Jim. We're going to look to get the team some rest, but maybe we can get you the remote camera setup time today.
Okay, great. Thank you.
Thanks. Okay, next up, Lenka White from Sputnik.
Good morning, everyone. Thank you so much for this opportunity. On the crew, please, I wanted to ask you, there have been a number of delays as of now. How do you ensure that they stay in good spirits? As you mentioned, do they receive some additional psychological support? Thank you so much.
Yeah, that's a good question. We've been talking to Butch and Sonny quite often. I would say they're in good spirits. When I've talked to them, they say, Steve, don't worry about us. We're eating well. We're going to the gym and we're exercising. We're listening to your meetings. We're spending a little time talking to family members as they stay in quarantine. They are both former military. They told me it's way better than being on an aircraft carrier. So don't worry about us is what they said. They'll be ready. They've also done some extra simulations, and they've gone over into Mark has a facility called the ASIL, which is an integrated hardware software lab. They've done some simulations with different failure cases and proficiency runs in the various simulators here. We have ways to get them into those facilities without exposing them, to people. We have what's called a health stabilization program, which protects their health. And so, they're in good spirits. And, again, they tell me don't worry about them. I think they worry about us sometimes more than we worry about them. So.
Thank you, Steve. Next question comes from Beverly at Space Scout.
Hi, thanks for doing this. So this is for Mark and maybe Steve. Looking at the big picture here, we faced a number of different challenges during the current Starliner CFT campaign. Could you talk a little bit about what kind of lessons learned or technical procedural changes are being made in the long term to support Starliner during its operational phase? Thank you.
Yeah, that's a good question. The whole design and development process, and as you go into operations, is kind of an iterative process. And we really take advantage of things like this where we can learn lessons and then apply them to either our designs, to our training, to the knowledge base that we have. And that's exactly what we've done. And I think our teams have done an excellent job, both on the NASA side and on the Boeing side, of researching these issues down to the nth level of detail so that we can apply either lessons learned to the mission that we're flying or to future missions, and then we go and make those improvements for the future. So there's really, there's always a silver lining to these things, and I think that's one of them, is that we learn and we apply those to the future.
That's a great response, Mark. Thank you. We're going to take one final question from Manuel Mazzanati from Exploración Especial.
Thank you, Stephanie. I think it's a question for Steve or Mark. I guess, I'm sorry if you answered before. You were mentioning that Boeing is evaluating a potential redesign of this potential system that could affect the deorbit burn. My question was regarding if this redesign needs to be achieved or is important to be achieved before the first operational flight. And I think you said no. I just wanted to be sure about that. And if not, so we are okay in the understanding and controlling the current situation for the first operational flight, correct?
All right. So for this mission, for the CFT mission, we have a workaround that we're all comfortable with, and that's what we explained today. For Starliner 1, we are looking at the potential solutions to this problem that will be a part of the permanent design. It's software changes, it's a potential hardware change, and then there's a couple other ideas that are out there. But we will implement for Starliner 1.
Thank you.
Okay, thank you. Jim, we have a response for you about remote camera setup. That will be 9 o'clock on Friday, May 31st. And I want to give a special thank you to our folks who stayed on the line much longer than we booked them for. So thank you to Jim Free, Ken Bowersox, Steve Stich, and Dana Weigel from NASA, and Boeing's Mark Nappi and ULA's Gary Wentz for sticking with us to ensure that every reporter got an opportunity to ask a question. And thank you to all of you for your interest in the efforts of NASA and private industry to expand access to space with the Commercial Crew Program. Please do stay tuned to learn more about NASA's Boeing Crew Flight Test online at nasa.gov, of course, nasa.gov/commercialcrew, and regular updates that are shared on the blog at blogs.nasa.gov/commercialcrew. And we, as mentioned, the teams are headed towards the Delta Flight Readiness Review next Wednesday, and we'll look to have another media opportunity on Thursday, the following day. So we'll get additional information sent out in a media advisory probably early next week for you all. Thanks again for joining us and sticking with us today as we talk through this update.